This conference will now be recorded.
So in the last class, we started with multi-threading. The main use of going with threads is to increase the performance of application. So whenever we want to create a thread, what we need to do? Just we need to create a class which extends thread and override run method. And how to invoke run method? How to invoke run method? By creating object of your thread class, and we have to invoke run method only by using start. And even we discussed the methods of thread class like current thread, set name, get priority, get priority, like this. Just we have seen the methods in the last class. Today, let us go with the next part. Like we'll be taking one more example to understand more of threads, how CPU is allocating time for our threads, that we are going to see practically. Then we'll discuss about how to create threads using runnable interface. Then we understand about synchronization, and finally interthread communication. Let us go with one more example to understand about threads. Multithread demo. So to store thread related programs, we have created a package threads. Right click on threads package and say new class multithread demo. Right now, in this one, let us create a class thread x extends thread. Let us create a class thread x extends thread. Then override the run method. Now, take the current details of thread. How to take current details? Thread equal to thread dot current thread. So what is the need of calling this method is when you want to change the name of the thread or priority, then you can call this method, else calling this method is not required. Now let us change the name t.setName to threadx. Now in this threadx, we want to print the numbers from 1 to 10. So to print, take a for loop for int I equal to 1, I less than or equal to 10, I plus plus. Then we'll print here t dot get name, which returns threadx, a separator colon and the value of I. So whenever we invoke run method, how the output will be? Threadx colon 1, threadx colon 2, like that, threadx colon 10. Let me show that. Coming to main method, main thread, create object of threadx, t1 equal to new threadx, then invoke run method only by using start. So when you say t1 dot start, it goes to run method. The code in run method will get executed. See the output here? It's printing numbers from 1 to 10. Now let us create one more thread class. Class thread by extends thread, override the run method, create object of thread, thread t equal to thread dot current thread, then say t dot set name thread by. So in this thread by, let us display the numbers from 10 to 1 so that we can differentiate easily. So for int I equal to 10, I greater than or equal to 1, I minus minus. Then print here t dot get name, which returns thread by separator colon and the value of 1. Coming to main thread, create object of thread by t2 equal to new thread by and invoke run method by using start t2 dot start. Now see the output. Output is important to understand here. See how we are getting, see threadx 1 to 10, thread by 10 to 1. We are not finding any multi-threading here. Let us run the code again. Run again. So I'm keep on running because how CPU is going to allocate time for our threads, that is not in the hands of programmer. See now, see, observe here, we are getting see thread x 1 to 6. After that, control is going to thread y. Again in between, again it is going to thread x. Again it is going to thread y. Again x, again y, again x, again y, again x. Means when run method of thread is getting executed, in between it is coming out, and even CPU is allocating time to run method of thread y. Again it goes to run method of thread x, again run method of thread y. Means CPU is allocating some time for run method of thread x, again some time for run method of thread y, which is proved by seeing this output. It is proved what? By seeing the output. Got it, everyone? See here how the output is coming. When you say t1.start, it is going to run method, and it is printing c thread x 1 to 6, and again it is coming out from run method of thread x, and again it is going to thread y. Again allocating time to thread x, again y, again x, again y, like that. If you see the output, it is clearly proved here. Means in the case of traditional programming, whenever we invoke a method, until the total method is completed, CPU will not allocate time to other methods at all. But in the case of multi-threading, in between, CPU can come out of method and allocate time to other methods, which is proved by showing this output to you. Now, instead of start, if I go with run, instead of start, if I use run, then how many times you run the program, the output will be always thread x 1 to 10 and thread y 10 to 1 only. How many times you run, the output will remain same, because this is not at all multi-threaded application. So we have to create a thread only by using start. Only when you say start, then only the object will become thread. Without start, no concept of threads. Again, this example code. Any questions? No. Once we print thread x colon 1, we want to make the thread to go to block state. How to make the thread to go to block state is by using the method thread.sleep, where we are passing 1000 milliseconds. Means for 1 second, the thread will go to block state. And see, we are getting error under sleep method. Keep mouse pointer on this error. See the message, unhandled exception type interrupted exception. Means sleep method throws interrupted exception. So whenever you call a method which is throwing some exception, then we have to call that method in between try and catch block, because it's a checked exception. Similar way, once we print thread by colon 10, we want to make the thread to go to block state, then call the method thread.sleep of 1000. Just keep mouse pointer on error and surround with try catch. Interrupted exception is a checked exception. Now see, when we run the program, see, it comes slowly. See, thread x colon 1, again thread x goes to block state, CPU will be free, so it's allocating time to thread y. Again x, again y, again x, again y. Slowly it is coming, because the threads are going to block state for given interval of time. In our example, for 1 second. So what is the use of sleep method? When sleep method is invoked on a thread, the current thread will go to block state for the given interval of time. Like example, thread.sleep of 1000. In this one, 1000 milliseconds. Means for 1 second. Now let us see how to create a thread using runnable interface. Creating threads using runnable interface. First of all, let us understand what is the need of going with runnable interface when you are able to create a thread using thread class. That let us understand first. If you take a class A and if you take class B, extends A, means B is a subclass of A now. Now we want to make B class as thread. Now we want to make what? B class as thread. Then can we say here comma thread? Is it possible in Java? Can we say comma thread here? In Java, can a class extend multiple classes? Is it possible? Does Java support multiple inheritance?
No.
No, right? Java does not support multiple inheritance. In Java, a class can extend only one class. But you are trying to extend multiple classes. This will go with error because does not support multiple inheritance. But the objective is we want to make B class as thread. Then the solution is we have to take class B, extends A, and say implements runnable. So when a class implements runnable interface, in runnable interface, it contains only one abstract method run. So we have to override compulsory. Override run method compulsory. So what is the point here? When to think of runnable interface, if a class extends another class, and to make this class as thread, the class should implement runnable interface, as Java does not support multiple inheritance. One more advantage is ensures that run method is overridden. Ensures that run method is what? Overridden. Okay, so if I extend thread class, since thread is concrete, overriding run is optional. Compiler will not give any error. But if I implement runnable, compulsory we have to override run method. Let us understand with a program runnable demo. Right click on package and say new class runnable demo. In this one, let us create a class threadr implements runnable. See, whenever you take a class which implements runnable interface, see the error. The threadr must implement the inherited abstract method run. So compulsory we have to override run method. That's the meaning called as ensures that run method is overridden. See, just a click here. Add unimplemented methods. The method will be overridden for us. The method is overridden. In this one, this override symbol, we call them as annotations, added in Java 5 version. Whenever you see symbol, they are annotations. What is the use of this annotation? By seeing this override, we can easily say that this is a overridden method, right? So as the days goes on, we will be learning so many annotations. By seeing the annotation, we can easily understand what is happening. Now, keep some logic in run method. So I want to just print from 1 to 10, some logic, anything. The main objective is how to invoke run. We are printing I value. Coming to main method, create object of threadr t1 equal to new threadr and say t1 dot start. Whenever you want to create a thread, we have to invoke start method. But observe, when you say t1 dot start, we are getting compile time error because in threadr there is no start method, and runnable also there is no start method because it contains only one method run. But the rule is we have to create a thread only by using start method. The rule is what? We have to create a thread only by using start method, but there is no start method here. Then the solution is, since start is a method belongs to thread class, we have to create object of thread class. Since start is a method belongs to thread class, create object of thread class and invoke start method using thread class object. Now see, when we run, no output. We are not getting any output because you are referring to thread class object. So whenever you say t.start, it will go to run method of thread class. When we say t.start, it goes to run method of thread class. Okay, and what is the point I have given yesterday? Run method of thread class is empty method, no code inside. That's the reason we are not getting any output. But the objective is we want to invoke run method of threader. Then the solution is to the constructor of thread. To the constructor of thread, you have to pass your runnable object. Since T is referring to T1 object, when you say t.start, it goes to run method of threader. Here, when we run, we get the output here. So when you go for runnable interface, we need to write one line extra. That is, we have to create object of thread. To the constructor of thread, we have to pass our runnable object. Right? Any questions? So very important, multi-threading, please recap. Practice it properly. Now, let us go with the next concept here. Synchronization. Very important, but very simple. Let us understand this using a diagram. Synchronization. Synchronization. Now let us consider we are having a bank account. We are having a bank account with a balance of 5,000. This account is accessed by X customer and also Y customer. So X and Y are going to access the same bank account. Then what type of account we call in banking terminology? In banking terminology, what type of account it is called as? Joint account. We call it as what? Joint account. Now, let us suppose at time t1, X checks balance. Time t1, X checks balance. So what is the balance now? 5,000. At time t2, X withdraws. Let me say 1,000. So whenever we say withdraw, let me say 1,000. At time t3, Y checks balance. What is the balance now? 4,000. At time t4, Y withdraws. This 1,000. Like that, they are going to do the transactions. At time t12, X checks balance, which is 1,000. Let us suppose now. At time t13, Y also checks balance. This 1,000. At time t14, X withdraws. X withdraws, which is 1,000. At time t15, when Y is trying to withdraw, it says insufficient balance. Insufficient balance. But just now it has shown why that 1,000 is balance, and immediately it is saying insufficient balance. So Y will get confused what is happening. So which creates ambiguities here, which creates confusions here. So the output what you are expecting, if you are not getting, if it is creating confusions, this type of problems we call it as concurrency problems. Call them as concurrency problems. Okay, so why we are getting concurrency problems? When two or more threads, if I consider X and Y are threads, when two or more threads access the same resource, then there is a chance of getting concurrency problems. What you are expecting, we may not get it. Let us understand why we are getting this problem. So if you take the code like void make withdrawal, which takes the amount as argument to withdraw, and here we write some lines of code for check balance, and we write with some lines of code for withdraw, the logic for withdraw. Now let us suppose it is a multi-threaded application. Now CP has given time to X-thread, CP has given time to X-thread to enter into this method, So X has executed this piece of code. X has executed this piece of code, means X has checked the balance. Since it is multi-threaded application, CP has given time to now Y thread to enter into this method. CP has given time to Y thread to enter into this method. So Y also has executed this piece of code. Y also executed this piece of code, means Y also has checked the balance. Now CP has given time to X thread to enter into the remaining piece of code. So X has entered into withdraw code. So X has withdrawn the money. Now CP has given time to Y thread to enter into the remaining piece of code. So since already the amount has withdrawn, we are getting insufficient balance. This is the problem here. Then the solution for this problem is very simple solution. The solution is very simple. Just we have to use a keyword synchronized before the method. That just to use the keyword synchronized before the method. So when we use synchronized keyword, when X enters into this method, until the total method is completed, Y cannot enter. When Y enters into the method, X cannot enter. Means only one thread will be running inside the method. There will be only what? One thread will be running inside the method. Then there won't be any concurrency problems. Just the solution is synchronized keyword we have to use before the method. So what is this one is? When two or more threads access the same resource, then there is a chance of getting concurrency problems. There is a chance of getting what? Concurrency problems. What is concurrency problem? I have elaborated in the diagram. Synchronization is used for concurrency problems. Synchronization is used for concurrency problems. Synchronized keyword is used for synchronization. Which keyword we use for synchronization? Synchronized keyword. Okay, the synchronized keyword can be used for a method or block of statements only. We can use synchronized keyword only at two locations for a method or even block of statements. Like example, if you take a method xxx, if the complete method is having concurrency problem, then make the complete method as synchronized. Now, if you take one more method like y, and in this y method, let us suppose it contains 100 lines of code. Y method contains 100 lines of code. In this 100 lines of code, only 10 lines having concurrency problem. Then if you make complete 100 lines as synchronized, performance will get degraded, because when we apply synchronization, only one thread will be running. But the problem is only with the 10 lines of code, then make only the 10 lines as synchronized here. In this case, we go for synchronized block. Go for what? Synchronized block. Very important statement. In a synchronized context, means either method or block, only one thread will be running. So in a synchronized context, only one thread will be running, which degrades the performance of application. Which degrades what? The performance of application. A small question here. Whenever we are developing software applications, which is important? Correctness of the application or performance? Out of these two features, correctness and performance, which is more important for us? Correctness, right? Because like example, if you consider, if you go to ATM and you want to withdraw 5,000, within seconds it is giving 5,000 to us. Sorry, within seconds it is giving 3,000 to us. Will you accept? No. Even though performance is there, but if it is not giving correct results, there is no use of your application. So correctness is more important than performance. So to achieve correctness, sometimes we may need to lose performance. That is a place where we use synchronization. Right? Let us understand with the example code. Right click on package and say new class synchronization tab. Here, let us take a class table with a method print table, which takes a number as an argument. So what is the number we give? We want to print the table for that number, a multiplication table like this. For I equal to 1, I less than or equal to 10, I plus plus, and we'll display here n into I equal to n into I. Now, so just whenever we call printable method, what is the number you pass? It's going to print the table for that number. Now, let us take a class thread A, which extends thread, and in this we go with the table as reference. We take a data member table. Now, let us go with a constructor. The constructor takes table as argument and will say this dot t equal to t. This dot equal to t means in the main method we create table object, then we create object of thread A, even equal to new thread A. The constructor we are passing table object as argument. So this t object will come and store into this t which we are referring here. Now override run method. In run method, by using this table reference, we'll call print table and we want to print the table for 5. And how to invoke run method here? t1.start. When you say t1.start, when we run, it's going to print the table for 5. So it's printing table for 5 here. Now, let us create one more thread class. class thread B, extends thread, then go with a table reference, then to the constructor of thread B class, pass table as argument, and we'll say this dot t equal to t. Now, so in the main method, when you create object of thread B, t2 equal to new thread B, to this we are passing table as argument. See, T1 is referring to same table T object, T2 also referring to same T, means multiple threads are referring to same resource, T resource here. Now, override run method. Here, by using table reference, we'll call the print table of 8. Then how to invoke run method here? T2.start. T2.start. See the output here. Thread A is taking care of printing table for 5 and thread B is taking care of printing table for 8. See here, see the result. So we are getting 5th table, after that 8th table, no issues. But let us run the program again, run the code again. See here, it is going to 5th table, in between it is going to 8th table, again it is going to 5th table like this. So which is not good output here. Means whenever we start printing one table for one number, until the table is complete, we don't want to print another table. But what is happening? In between only it is printing another table here. So we are not getting correct result. So the solution is, wherever you are printing the table, make this method as synchronized. When you make the method as synchronized, only one thread will be running. If 5th table starts here, until the 5th table is over, the other thread will not enter into this. If 8th table starts, until 8th table is over, the other thread will not enter into this. So we get the proper result here. Clear everyone? So it's simple, it's very simple to use. When multiple threads are referring to same resource, just to use synchronized keyword here. Any questions, anyone?
Sir, can you please explain line 14?
Line 14 is in our classes thread A or thread B, we are taking this table as data member, a property. Okay, so this table object you are creating here, it's a reference. We call it as reference. And how we are giving value to this data member? Using constructor. Using
Okay,
constructor.
we don't have to declare data type for a data member.
Come on, this is data type only, right? So don't think that data type means only int, float, char, double string like that. So data type means it can be any class also. Class is also a data type, right? If you remember the object oriented, if you take class employee, or if you take class account as customer, when I say account as customer, we'll take care customer C as reference, right? Where customer is one more class. Where customer is one more class. So how to write? Account as customer means how will you write here? Customer. Okay. So one more example, if you take class book, class library as books, right? Library as books. Then how will you write here? Book B. So where B is a reference of type book type. So data type means what are the different data types we are having? Primitive type and reference type. Primitive means all like int, float, char, double are primitive. Reference are what? Classes. So classes also data types only.
Okay,
Clear,
sir.
Kalyan?
Yes, sir.
Right?
Thank you.
Now, let us go with the last one. Very, very important one. Interthread communication. Like example, let us suppose we are having thread 1 which is doing a task. Once the task is complete, we get the result. Once the task is completed, we get the result. And this result want to be taken by thread 2. The result want to be used by thread 2. So thread 1 is doing the task. Once the task is complete, we get result, and the result want to be used by thread 2. Now let us suppose that when thread 1 is doing the task, in between only, before the task is completed only, in between only, if thread 2 takes the value of result, we get wrong results because the result value is not totally ready. In between only, thread 2 is taking value of result, so we get wrong results. So this is the place where they are to communicate. So thread 1 has to inform thread 2 that I'm doing the task now. Once the task is complete, when the result value is ready, we'll let you know, then you can take the value of result. So this concept only we call interthread communication. So how it is done is, it is done using wait, notify, and notify all methods. It is done using what? Wait, notify, and notify all methods. These methods belongs to object class, not thread class. These methods belongs to object class, the topmost class in Java hierarchy. The use of these methods is, when thread 1 is doing the task, we need to make thread 2 to go to block state because thread 2 should not take value of result. So when thread 1 is doing the task, we need to push thread 2 to block state. When the result is ready, we have to inform thread 2 to come back again. So for that, when wait method, for this we use when wait method. When wait method is invoked on a thread, the other threads will go to block state. Go to block state until notified using notify or notify all methods. Whenever you want to make a thread to go to block state, we use wait, and when that result value is ready, we'll inform to come back again using notify or notify all. Then, what is the difference between notify and notify all? Very simple difference. If there is only one thread in block state, we use notify method. Else, for one or more threads in block state, we use notify all. Notify is only for one thread, notify is for one or more threads. Very important statement. These methods need to be used in synchronized context only. These methods need to be used in synchronized context only. Means synchronized method or block. Else it will throw illegal monitor state exception. It will throw what exception? Illegal monitor state exception. Now let us understand this concept with a program. Interthread demo. Right click on package and say new class interthread demo. In this one, let us go with the class thread sum, which extends thread. Take a data member sum, then override run method. In this run method, the task what we want to perform is, we want to find sum of 1 to 100. How to find sum of 1 to 100? Take a for loop, that's at 1 less than or equal to 100, I plus plus, and say here sum equal to sum plus I. So whenever we invoke run method, it's going to find sum of 1 to 100. Coming to main method, main thread, create object of thread sum, ts equal to new thread sum, and invoke start method, ts dot start. So which goes to run method and finds the sum of 1 to 100. In main thread, display the value of sum. Put it at ts dot sum. So who is doing the task here? Thread sum is doing the task, and who is taking the result? Main thread is taking the result. Main thread is taking the value of result. Now see the output here. when we run, we are getting some as what? 0, which is wrong output. So sometimes you may get correct result also. Sometimes you may get some other number also, but you are getting 0. Why we are getting 0? Let us understand. When you run this application, which thread goes to runnable state first? Main thread. Main thread will go to runnable state. After that, when you set ts.start, ts also goes to runnable state. Now, can you guarantee which thread will get executed first here? No guarantee. So yesterday I mentioned our work is only to push the threads into runnable state, but for which thread your CPU is going to queue time, that is not in the hands of programmer. Let us suppose if CPU has given time to main thread, this line of main thread is left out here, so which is going to take the some value which is 0, because this run method not got executed yet. CPU did not time to TS thread at all, so it won't before it enters into run. CPU has given time to main thread, so when this line of main thread is executed, it is taking some as for default value 0. Now the objective is this line of main thread should not get executed. This line of main thread should not get executed until the for loop is completed. Then what we should do? We have to make main thread to go to block state. How to make main thread to go to block state? Using the method ts.wait. So when you say ts.wait, the other threads, who is other thread here? Main thread will go to block state. So this line of main thread will not get executed. And wait method throws interrupted exception. You can add throws declaration, throws interrupted exception. Now, when we should inform main thread to come back once the for loop is over, inform main thread to come back to runnable state by using notify or notify all. That's it. Now see, when we run, we're getting exception, illegal monitor state exception, because we have to call these methods in synchronized block only, like this synchronized context. Synchronized of the object name, which is calling wait method. Notify also synchronized of this, because we don't know which object is calling this run method, so we'll mention the current object this. Now see, when we run, how many times you run, we get the correct result 5050. So very important, please recap it. So complete multi-threading is important, and many questions you will face under multi-threading for interview time. If you recap and practice, you can easily answer this. Right? So, any questions, anyone? Yes, Sarita.
Yes, sir. I have. Do you have sometimes? I need a do while loop. Can you explain in?
What is the difference between while loop and
I'm
for
little
loop?
bit. Yeah, while for loop. Sorry.
They are for looping purpose. They are used for looping purpose. So either you can use while loop or do while loop or for loop. It depends. So when you are having conditions like ch not equal to 4, ch not equal to 1, such type of conditions, n not equal to 0, such type of conditions, either you go for while loop or do while loop. And for loop we use mainly for sequences. Clear, Sarita? When to use for loop? Sequences. Sequences we go for.
Loop
Then
when the
what?
condition is
Yeah, yes, Sarita, you say first.
when the condition is true.
Yeah, when the condition is true, it will enter into the statements.
Okay.
So, what is the syntax? While condition, right? While condition. So when the condition is true, it will enter into the statements. Then like that, it will be keep on repeating the loop, and when condition becomes false, comes out. When condition becomes false, comes out. Then in the case of do while also same. But what is the difference? In the case of do while, the condition is checked after the statements. Okay. The condition is checked after the statements. So when to think of do while loop over while loop? When the value of condition, this is our condition, no? When the value of condition is known in the loop statements, In the loop statements, if you are accepting condition value, like example, we have taken this program, no, the bank program. So here in this one, in this example, this is the condition, right? This is your condition. So what is the condition here? We are having menu like 1, 2, 3, 4. When the choice is 4 means exit, we have to come out. So where you are accepting this condition value, this is our condition here. Where you are accepting condition value in the loop statements here. Do is started here, while is here. So where you are accepting the condition value in the loop statements. When you are accepting the condition value in the loop statements, then in that case we go for do while loop. So for this type of conditions like ch not equal to 4, n not equal to 0, for such type of conditions we use either while loop or do while loop. But for sequences, for loop. Sequence means what? 1 to 10, 1 to 100, 100 to 200. That is called a sequence. For sequence, we go for loop. Clear?
Yeah, clear. Thank you.
Practice. You have to practice more and do some examples. Whatever the task I've given you, if you practice, you can easily know when to use loops.
Okay.
And no rule that we have to use while loop only, do while loop only, for loop only. Any loop you can use. It's up to us. Okay. So in the next class, Monday, we are going to start off with one more very, very important topic, collections. Okay, don't miss the classes of collections. Very important one. Right. Thank you all and happy weekend.